Hello, this is Dr. Mahesh Kalyan Shetty, a team leader, along with my colleague team members, Professor Chetan Kunapure, Professor Bipin Patil from Department of Civil Engineering, Walchand Institute of Technology, Solapur. This presentation is devoted to the introduction to shear force diagram and bending moment diagram. The learning outcome of this session will be at the end of this session, student will be able to define the shear force and bending moment, and students will be able to derive the relationship between shear force diagram and bending moment diagram. For the understanding purpose, let us consider one simply supported beam as shown in figure. One end is a hinge one and another is a roller support subjected to 3-point loads. The distances between the loads are given here. So to find the shear force and bending moment, first of all, we need to determine the reactions of the beams by considering the simple static equilibrium conditions. So the reactions are determined here as 8.2 kilonewton Ra and Rb is 14.8 kilonewton. After this, let us consider a section XX at a distance of 6 meter from the left hand support A as shown here. And now imagine the beam is cut into two pieces at section XX, and due to this section now the beam is separated into two parts as shown here, left hand side and right hand side, and there are few forces present on the left hand side and few forces present on the right hand side. Now, to find the forces experienced by this particular section, consider any portion of the beam. That means either you consider the left hand side or right hand side, and accordingly we can write what is the transverse force experienced by that section. So if I consider the left hand side, you can see here there are only two forces present. So upward forces consider positive, downward forces consider negative. So the unbalanced vertical force experienced by that section is 8.2 minus 5, that is 3.2 kilonewton upward. Now if I consider the right hand portion of this beam, we get again you consider the right hand side and there are three forces present. So again calculate the unbalanced vertical force. So considering the vertical force, upward force positive, downward force negative, so we get unbalanced force as 3.2 kilonewton downward. So uh, of course at that particular section we have the moment also present. So the moment experienced by that section, considering the left hand side, is again see 8.2 into 6 minus 5 into 2. So the moment due to these two unbalanced forces, so it is equal to 39.2. And the right hand side, if I consider, just now we discussed that the shear force experienced is 3.2 kilonewton, which is same as that of the unbalanced force if I consider the left hand side. So it means that either I consider the left hand side or right hand side of the section, I get the same unbalanced force. And also the moment also, you can see if I consider the right hand side, we get the same unbalanced moment 39.2. So which indicates that at that particular section, if I draw or if I show the unbalanced vertical force and unbalanced moment, it is like this 3.2 and 39.2 considering the left hand side. Considering the right hand side, we get the same unbalanced force 3.2 and unbalanced moment is 39.2, only with the opposite sign. So therefore the section XX which is considered for this problem is subjected to force 3.2 kilonewton and moment 39.2 kilonewton meter as shown in figure. Now this unbalanced force is trying to shear off the section and hence is called as shear force, and the moment which is present here at that section will try to bend the section, therefore it is called as bending moment. So we can have a definitions of this shear force at a section that, so it is algebraic sum of the vertical forces acting on the beam either to the left or right of the section, which is known as shear force at that section. In the now this is what is the unbalanced force. In the same way, bending moment at a section is the algebraic sum of the moments of all the forces acting on the beam either to the left or right of the section is known as a bending moment. So these are the values which are obtained for the problem which I considered. So the shear force is 3.2 kilonewton and bending moment is 39.2 kilonewton meter. Now we have a sign conventions for these shear force. So this is a sign convention which is used for the shear force. So on the right hand side of the section, if we have the force is downward and left hand side it is if acting upward. So this is a shearing action created. If this kind of shearing action is present at the section, it is called positive shear force. And if you have opposite kind of shear forces, right hand side acting upward, left hand side downward. So if you have this kind of shearing action at the section, it is called negative shear force. In the same way, for bending moment also we have a sign convention. So it is called the positive bending moment is called as a sagging bending moment if it tends to bend the beam into a curvature having convexity at the bottom as shown in the figure. So if you have a bending such that the convexity is present at the bottom, then this kind of bending moment is called as sagging bending moment and is considered as positive bending moment as shown in figure. So this kind of bending moment if you have which creates the convexity at the bottom, then this is called as positive bending moment. Whereas if you have a opposite kind of bending as shown here, if it tends to bend the beam to a curvature having convexity at the top, you can see here if you have a convexity at the top, then that kind of bending moment is called as hogging bending moment, which is considered as a negative bending moment. So these are the sign conventions for bending moment. Now with these values we can construct the diagrams. So we have basically two diagrams called shear force diagram and bending moment diagram. So the diagram which it shows the variation of shear force along the length of the beam is called as shear force diagram. Just now we have seen the shear force at a typical section. So if this shear force is represented graphically along all the sections in the beam, then that diagram we call it as shear force diagram. In the same way, the diagram which shows the variation of bending moment along the length of the beam is called as bending moment diagram. So in the diagrams, especially in the bending moment diagram, we get one typical point there. Usually uh, for some typical types of beams we get, not all the time, uh, where we get one uh, point where the bending moment changes the sign. Say here it is written, it is the point on the bending moment diagram where bending moment changes the sign from positive to negative or vice versa. So it is also called as inflation point. At the point of inflation or contraflexure, the bending moment is 0. So this let us consider one diagram and let us discuss about the relationship between the load, shear force and bending moment. So there exists always some relationship among all these diagrams. So for that, if I consider this simply supported beam subjected to some haphazard loading as shown here, and if I take a small elementary length of this beams of having length dx, which is been uh, comprised by a section xx and x1 then we can consider the free body diagram of this small elementary length. On the left hand side there is a shear force bending moment present, on the right hand side also along section x1 there is some shear force and bending moment with some magnitude, and this length dx is subjected to uniformly distributed load W. Now if the free body diagram of this is drawn, then if you take a summation of moment about O point here, which is shown here, so we get this equation. So considering anti-clockwise moment as negative, clockwise moment as positive, we get this equation wherein it consists this moment, this shear force, then this moment, and the loading present on this section. So neglecting the small quantities, further this equation reduces to this V dx is equal to dm. So here we can see this equation reduces to this small equation which is called as V equal to dm by dx, which indicates that V is nothing but it's a shear force is nothing but it's a rate of change of a bending moment diagram, or in other word we can say that the slope of the bending moment diagram is nothing but the shear force. So this relationship between the bending moment and shear force. In the same way, if I consider the another condition that summation of all the forces in a vertical direction equal to 0, I will get this equation, and again neglecting the small terms, we get this equation, which is again nothing but it is a rate of change of shear force is nothing but the loading. Therefore, in other words, I can say that the slope of the shear force diagram is nothing but the loading. So in this way, we can derive the relationship between the bending moment diagram, shear force diagram, and the loading present on the beam. Now these are some guidelines. So variation of shear force and bending moment diagram. So for standard loads, how these particular diagrams will look like. Here you can see the type of load is present on the horizontal uh, uh, direction here. So and in here shear force and bending moment diagram, how it will look like. So for example, between point loads or for no load regions, the shear force diagram is always horizontal. Uniformly distributed load, the shear force diagram is inclined. Uniformly varying load, the shear force diagram is 2-degree curve. In the same way, for a bending moment diagram also we have some these guidelines. If you have uh, between the point loads or no load region, we get an inclined line. Uniformly distributed load, we get a 2-degree curve. Uniformly varying load, we get a 3-degree curve. And if you look at this shear force diagram and bending moment diagram, it is observed that the bending moment diagram is 1 degree ahead of shear force diagram. So if you have a shear force diagram horizontal line, you can see it is inclined. If the shear force diagram is inclined line, then it is a parabola of 2 degree. And if the shear force diagram is 2 degree curve, then the bending moment diagram is 1 degree ahead, that is 3 degree cubical curve. So in this way, we can use these relationships to draw the diagrams quickly. Thank you very much.